So next we have a fraction problem that doesn't have a common denominator, and you need one anytime you're adding fractions. If I just look at the numbers, I see a 4 and a 2. The least common multiple would be a 4 for these. Yes, you could make them both an 8 and you wouldn't be wrong, but the smaller you make your denominator, the less reducing you do at the end. So we're going to stick with the 4. I see they both have an x to the third. We don't need to change that, so we'll include that. One of them has a y, so that means they're both going to need to have a y. So in the end, we're going to make them both 4x to the third y. So conveniently, the first fraction already has that denominator. That first fraction is not going to change at all at this time. We need to change the second one. It has a 2, it needs a 4, so we're going to multiply by 2. The x cubed is fine, but it does need the y. So ultimately, we're going to multiply that fraction by a 2 and a y. If we do it to the denominator, though, we have to do it to the numerator. So by doing that, we're going to keep the first fraction the same. 5 times 2y becomes 10y, and that created our denominator of 4x to the third times y. When you have a common denominator, you'll keep its common denominator when you add. And when I look at the numerators, they are not like terms. You cannot make that an 11 or a 9 or anything with a y. They're separate. You can only write them next to each other, 1 plus 10y, all over the denominator of 4x cubed y. For part B, you still need a common denominator when you're subtracting. They both have the number 2, so conveniently we don't need to change that. They both have x's, but one of them is an x to the first, one of them is an x to the third. Anytime you're searching for that common denominator, you need to take essentially the biggest one, the one with the largest exponent. So we're going to make them both have an x to the third. We're also going to make them both have a y, because there's a y in the fraction on the right, even though there's not the one on the left. So we'll force the one on the left to have it, which means our common denominator will be 2x to the third y. So that right fraction is already ready to go. It's the one on the left that needs some more x's and a y. It already has one x. If we multiply it by x squared, it would get us 2 more, totaling to 3 x's. So we're going to multiply that left fraction by x squared so that we get to the third, and times a y, because it didn't have a y to start out with. So then x squared y is going to be multiplied in the numerator. We're just going to multiply it by a 1, so that's just going to make x squared y over our denominator of 2x cubed y. The second fraction is still just sitting there waiting because we didn't change anything. But once you have a common denominator, you keep that denominator. We don't have like terms in the numerator, so we're just going to write them next to each other as a subtraction problem.